We are going to talk about specifically the Caesar cipher. The Caesar cipher is a shift in the alphabet, and the alphabet wraps around. This is important because that means that if we take a number like Z and we were to shift 4 units down, we would wrap back around the alphabet. This image does a very nice job of showing how the numbers wrap around. You can see here that F maps over to C, and then A would map over to X. So in this case, this is a shift backwards, 1, 2, 3. So this would be a shift up 3. So you can see that F maps 1, 2, 3 back to C. It is important that we assign a number to each letter in the alphabet. We start with 0 for A, and we end with 25 for Z. This is related, as we've seen in our discussions about clock arithmetic, to the modulo 26 being a number between 0 and 25. Let's do an example of a classic Caesar cipher. We are going to decode this cipher, and we know that when the cipher was made, everything was shifted down 11. We will start off by taking each letter that is given and writing its numerical value. So L in our chart, we see here, is 11. So we'll write down 11. We'll continue with W is 22. X is 23. And so on and so forth. Since the word we were given is gibberish, we know that it was shifted down 11 from our initial one. We're going to add 11 to everything that we have in the second row. So we are going to add 11 just so that we can see. So we get 22, 33, 34, and so on. So you'll notice that some of these are values that are bigger than 25, namely this one, and these two here. So these are values that are not going to show up on our chart because they are bigger than 25. But remember, with clocks, we can go around and around and around so long as we go around the number of hours that are in a day. In this case, our magic number, I'm just going to write it here, is 26. So I'm going to subtract 26 from those numbers that are bigger than 26. So this one will stay the same. We don't need to do it there or here or in these two. But in the others, when we subtract 26, we get 7 and 8 and 10 and 4. Now we're able to look up the letters that correspond to these new numbers and decipher our word. So looking at 22 right here, we find 22 is W. So we get W. Using this 7 here, we see 7 is an H. So 8 has to be an I. We're going to use the 18 that was up here because it was within our range. We see that 18 is an S. K, E, R, S. Whiskers. Now we are going to decipher a word. We're going to decipher the word creation. I have gone ahead and in this first row here taken each letter and written its numerical representation. And we are going to shift this one down 7. So shift down 7, which means I'm going to go down 7 spots So in this column, in this row, I will, oops, wrong one. In this row, I will add 7. So this will become 9, 24, 11, 7, 26, 15, 21, and 20. So you can see the only problem that we really have with something not falling on our list is going to be right here. And again, I will be able to subtract 26 if needed. So this is going to become a 0. Everything else will stay the same. Now we will go back to our column with our letters here. We see 9. Look up 9. 9 becomes a J. 24 is Y. 11 is L. H. A. 15, looking that up, becomes P. 21 is V, and 20 is U. So if we were to encrypt the word creation using a shift of down 7, again, we would add 7. We can see that what we would send to our counterpart is JYLHAPVU, and then they would be able to decipher that.